Hello. Good morning to everyone. I am JC Peralta from the Ateneo de Manila University of the Philippines, and in behalf of my advisor and co-author, Dr. Narisma, I am presenting our work about the influence of warmer sea surface temperatures in the South China Sea over the southwest monsoon rainfall in the Philippines. So this southwest monsoon this term is actually a local terminology for that part of the Asia-Pacific summer monsoon, West Northern Pacific division. So here, this part is our southwest monsoon, and locally we call it Habagat. And this climate system is important for us because it accounts for around half of our the rainfall that falls in the Philippines, and it is most active during the months of June, July, August, and September. And the parts most affected is the western coast of the Philippines. Now, this is very important for us since over these areas we have our important agricultural sectors, as well as our dams for energy generation and also for domestic use. So any change in the rainfall amount or the timing of these rains brought about by the southwest monsoon will definitely impact these sectors and our national economy as a whole. And in fact, there has been a change noted in the rainfall amount due to the southwest monsoon. So in this paper last year by Dr. Cruz, which is my colleague also, she notes a decrease of about 0.026 to 0.075 per decade in total southwest monsoon rainfall over the western coast of our country, which should have been the areas where the rainfall is significant. So we noted that for the past 50 years. And we contrast this drying trend with this mode that we call the Habagat Typhoon Enhanced mode. And this occurs whenever typhoon tropical storm crosses over the northern latitudes of our country. What this does is that it greatly amplifies the flow of the southwesterly winds of our southwest monsoon, and that it produces a catastrophic amount of rainfall over our country, and images such as that one is very popular in our media. There are widespread floods over our urban areas, and this particular event, we call it the Habagat 2012 event, which happened August 1 to 10 of 2012. There were two typhoons that amplified the southwest monsoon, Haiku and Saula, over those dates. And this is the result. Catastrophic floods that are comparable, the damages are comparable with the strongest of our typhoons that hit the Manila and other urban areas. And so, like Dr. Roxy and the previous speaker, Kajikawa Sensei, we suspect that it is the sea surface temperatures that is the culprit of both modes of the changes in our southwest monsoon. So to be able to know that, we have methodologies for both modes. So ours is very modest analysis compared to the other speakers, but these are our findings. So for the long-term mode, we are analyzing a three-decade period, 1983 to 2012 of GGAS. And for data sets, we have three for SSTs and rainfall and horizontal winds, NOAA OI SST, RSST, and COVI SST. NNRP2, ETA interim, and JIRA analysis. And for the typhoon enhanced mode, we are using numerical simulations, particularly Reg 04 by ICTP. This is our domain. We downscaled from 40 to 25. The time period is the Habagat 2012 time occurrence event. And we compared it with trim data, and the SST we use is the weekly SST from NOAA, and our boundary conditions, initial conditions are from NNRP1. So we first go to the long-term mode. This is a simple time series of the values over those particular areas for SSTs and rainfall. We see that for the three data sets, there's a consistent increase, and it's around 0.4 degrees Celsius for this area for the past 30 years. Now, for rainfall also, there's an interesting decrease for those three data sets, and it's around from NNRP to it's around 740 millimeters per year decrease. We want to visualize this spatially. We did that by taking the difference of the recent decade, 2003 to 2012, minus our base decade, which is 1983 to 1992. And here are our results. So for SSTs, over this area, we see a consistent increasing trend for over the past 30 years, for June, July, August, and September. And for the rainfall, there's also a consistent decreasing trend over the northern part of this box over the Philippines, which confirms Dr. Cruz's findings here, here for August, and for September, there's none. So when we try to look at the horizontal winds, over those areas where we noted that the SSTs are increasing, there has been a decrease in the horizontal winds. So it's very prominent in June and August. For July, there's a slight one, but for September, we see actually an increase. So we try to relate these trends by a very simple linear correlation. So we selected these domains as our data point sources because they are the areas of most of significant increases in rainfall, increases in SSTs and decrease in rainfall. So we used OA SSTs for our correlation plots because it's the highest resolution data that we got. So for the three data sets, for relating SSTs and rainfall, we see a decreasing relationship, a negative relationship, consistent, but however the R-squared values are still low, and we try to improve that by bringing in the horizontal winds into the picture. So those are the areas where we got our data points. So each data point, I forgot to mention, is a month. So there. So we see that for this one, SSTs is actually negatively correlated with wind speeds, and wind speeds are positively correlated with the rainfall over that area. And we see an improvement with the R-squared value. So this is a stronger relation. This is a stronger relationship. So to summarize our results for the long-term mode, so here's the southwest monsoon winds, and that's the warming South China Sea. And once the winds pass over that area, they weaken by a mechanism, and thus it produces, the winds are correlated, highly correlated with the rainfall, and thus it produces scarcer rainfall conditions over the Philippines. What could have actually caused this decrease in the winds via the warming South China Sea? Well, we try to look at vertical winds and moisture, but the correlations are really low. The next part of our analysis would be to look at sea level pressure and maybe yes, an upper level analysis. So we now go to the short term typhoon enhanced mode. So this is the rainfall distribution for TRIM, and this is the approximate location for the two typhoons that enhance the Habagat. So we see that this is really a large amount of rainfall. For some areas, it fell over the 900 to 1,000 range, which is for 10 days only. the normal average rainfall for the whole of August is around, August in the country is around 600 to 900 only. So that all of that rainfall fell on only 10 days. So that is really a disaster. So this is the HCM4 model that we got. So it captured the distributions over that area. This is our impact area, so this is really important for us. However, there's a wet bias over the Ilocos coast there. And dry bias over the brown regions, over the Manila Bay and the West Philippines Sea near the Zambales province. Um, so Um, so we tried to see whether SSTs could have been the culprit also for this disaster that happened in our country. So we tried to plot SSTs 3 weeks prior to that event and during that event for 2012, and this is the result. And we did that also for the 30-year period that we considered. So actually, this is a very common SST distribution for the South China Sea, and there's nothing unusual. It's really just the winds of the typhoon that amplified and produced that much rainfall in our country. However, there are significantly warm scenarios and cold scenarios. So we try to plug that into our model, and we try to see whether the waves would change on also the winds and also the moisture. So this is a result. So I will pick only one for the warm scenarios and one for the cold scenarios. So this is for the 2003 period. So we saw an increase in rain about 50 to 75% over the areas where the model captured the rainfall of TRIM, and we see actually stronger winds by around 5 to 10%, and an increase in the moisture level over most of the regions from around 2 to 6%. And this is for our cold scenario. So this is SST there for 1985. We got a negative 20 to negative 40 degrees rainfall, and minimal increase in rains over decrease in winds over this area, and for moisture there's actually an increase. So this is our summary for the Habagat Typhoon Enhanced Mode. So here is your normal southwest monsoon winds, and then they encounter the warming South China Sea. However, whenever there's a typhoon, and coupled with the typhoon, there's moisture increase associated with the warming of the seas. And there, the typhoon pulls the winds, and it infuses the air over the warm South China Sea, infuses that over the passing winds, and thus, coupled with that enhancing effect of the typhoon, we experience this extreme rainfall in the Philippines. And so, ayan, I give you my two diagrams again. And just to summarize our results, we see that for the Southwest Monsoon, there's a dual effect of the SSTs. One, for the long term, it's actually pointing to a drier condition over our country. However, whenever there's a typhoon, there's a possibility that extreme typhoon-enhanced rainfall events could yes, be also triggered by the SST values. And so that's the effect of the influence of warmer sea surface temperatures that we got. And thank you very much for listening.
Anything else or comment from Flo?
So, it's a very interesting study, I mean, something different. And recently, I think you had the warm SST anomalies over this region and several cyclones also. I think you might have got enhanced rainfall over the Philippines.
Yes, that was typhoon last week, and it hit roughly this part of our country. It's near Manila. We saw that effect only for the typhoons that pass over near Taiwan.
Towards Taiwan, right?
Yes, and it probably was blocked by our mountains in Manila. So we didn't see that much rainfall.
So the last, thank you very much.